We're going to concentrate on something called synthetic division this week. And you may remember from an algebra class in high school, a long division problem, which was an ugly division problem where we had multiple steps. And we're going to see that synthetic division, fortunately, is quite an easy process and strangely enough involves no dividing whatsoever. So we can use synthetic division if what we are dividing by contains just a single x with nothing but 1 in front of that x, and it's being added or subtracted from a number. And let's notice that's the case in each one of these that we're getting ready to try. They all have an x, and they're added or subtracted. A number is added or subtracted from x. So we can do synthetic division for all of these problems. So let's start with this first one. When we're doing synthetic division, we're going to look at this thing that we're dividing by, and we're going to leave the x out. We're just going to put the opposite of this number that's in that factor. So we're going to put -1 on the outside of a division sign. So let me use a draw feature. On the inside of the division sign, I'm going to put all of the coefficients of the thing that I'm dividing into. So 1, 1, -4, -4. Notice that no x's go into this. Notice also, because this is very important, my exponents have to be in descending order to begin with. So 3, 2, an unwritten 1, and then of course the constant. Okay, now, we always start the process by bringing the first number down, and then it becomes repeatedly multiply, add, multiply, add, multiply, add. So I'm going to multiply. -1 times +1 is -1. We add the column. All right, now I'll repeat, multiply, add. So -1 times 0 is 0. Add the column. That's -4. And I'll repeat, multiply, add. -1 times -4 is +4. Add the column. That's 0. Now, if I get a 0 in this last column, right here, it means there was no remainder and it went into it evenly. But when we're done, regardless of whether we have a remainder or not, we want to list our answer. And since I started with something to the third power, my answer is going to be 1 less in degree or exponent than what I started with. So my answer is going to start with an x squared, and this is the coefficient of that x squared right here. So my answer is x squared. This would normally be where we'd have our x, but it's a 0, so meaning there are no x's, so we're not going to list an x, and then I have a -4. So the answer to this division is x squared minus 4. Now, we'll look at another one. Let's divide x to the 4th minus 64 by x minus 2. So we're going to start by putting the opposite of the -2 out front. So we'll put a +2 out front. Now here's where we need to be careful. Up here we had an x to the 3rd, and then an x squared, and then an x to the 1st, and then the number out to the side. And we always have to have every single exponent accounted for. So I have a 1 in front of my x to the 4th. That's going to go first. But let's notice there's no x to the 3rds, so I need a 0 for that. And there's no x squares, so I need a 0 for that. And there's no x's, so I need a 0 for that. And now I can put my -64. So we have to account for every exponent. Here's the 4th power, 3rd power, 2nd power, 1st power, and finally the number. All right, now let's do the division process. Bring the 1 down. And now multiply, add, multiply, add, multiply, add, multiply, add. So 2 times 1 is 2. And let's add. 0 and 2 is 2. Let's do that again. Multiply, add. 2 times 2 is 4. Add the column. That's 4. Again, multiply, add. 2 times 4 is 8. Add the column. That's 8. 2 times 8 is 16. Add the column, let's see, that's negative 48, if I've subtracted correctly. Okay, now notice this time we have a remainder, okay? So we're still going to write our answer, but this time it's going to have a remainder. We started with division into x to the fourth. So this will start with an x to the third. So that's 1x to the third. This is x squared, so it'll be 2x squared. This is our x place, so that's 4x. And then this is just our constant 8. Now, what we do with a remainder is we take a remainder, negative 48, and we put it over the divisor. That's this. So there's our answer to that division problem. All right, so let's look lastly at this one and take it through the process. We have x minus 1, so we want the opposite of the minus 1. We want positive 1. We want 3. Our x squared has a negative 2. Now be careful. Notice there's no x there, so we need a 0 for the x to the first power, and then a 3. Now let's do our process. Bring down the 3. And now we'll multiply, add, multiply, add, multiply, add. So 1 times 3 is 3. Add the column, we get 1. Now let's multiply, add again. So 1 times 1 is 1. Add the column. And let's multiply, add again. 1 times 1 is 1. Add the column. Give 4. All right, so we again have a remainder. So we'll get ready to write it with a remainder. So we started with an x to the third. So this is going to be an x squared. So we'll have 3x squared. This will be our x place, so 1x, or just x. And then there's the constant 1. And now for our remainder, we take our 4 and put it over the divisor, x minus 1. And there is our division problem.